So is it that way?
No, it's right there. That way. That way. We'll get lost. That way.
Hey, are you guys lost?
Yeah.
Well, I live here. I can help you out. What are you looking for?
The CN Tower.
Oh, our world's tallest building?
Yeah.
You can't see it because of all these big buildings, but I can show it to you on the map. Okay, we are here now, and the CN Tower's over this way. So you got to go that way and then go left.
Okay.
Thanks.
That way left. Okay, bye. See you. Hi, I'm Bob McDonald. You know, it's really easy to get lost in a big city. There's so many lights all over the place, even if you have a map. Well, have you ever looked up into the night sky and wondered where we are in space? How do we fit into the grand universe? Well, keep your heads up, because we're going to discover our cosmic address. There is so much to see when you keep your head up. And it all seems so vast, so big, the stars just seem to go on forever. Have you ever wondered how big space is? How high is up? And more importantly, how do we fit into all of that? You know, those are questions that people have been asking for millions of years, as long as humans have been looking up at those bright lights in the sky. It'd be really neat if we could just jump into a spaceship and go rocketing around and find out what's out there. But unfortunately, our rockets are so slow, it takes more than your whole lifetime to get to even the nearest star. We do have big telescopes that are beginning to see out there, and they're starting to build up a picture of what the whole thing looks like and where we fit in. And you better get ready for this. We are not very important. Okay, here it is. We live on a planet that's just one of 8 other planets that circle our sun, which is only one star among billions of others that form our galaxy, called the Milky Way, which is only one galaxy among billions of others that are scattered across the expanding universe. So, did you get all that? Okay, let's take it one step at a time. First of all, we live on a planet. What's a planet? Well, a planet is a ball. Like this one, for example. Now, it's hard to believe that we live on a ball because if you just go outside and look at the Earth, it looks flat in most places. In fact, you can even take one of these levels that carpenters use, and if you put it on the ground in most places, or you put it on the floor of your house or your school, it will show you that it is level. The ground is flat. So, how can something that looks flat to our eyes actually be a ball? Well, if you can imagine yourself being really, really tiny, and you put yourself on the surface of this ball, you'll be so close to it that it will look flat, because you can't see the whole thing all at once. That is our human perception of planet Earth. We are so tiny compared to the Earth that it looks flat to us. In fact, it took a long time for us to figure out that the Earth was a ball. First, we had to invent ships to sail around it. Then we had to invent airplanes to fly around it. And finally, we invented spaceships.
Liftoff. We have liftoff at 9:34 a.m. Eastern Daylight Time.
That could carry us high enough out into space that we could back off and look at the whole Earth at once. And what did we see? A ball. Not only that, this ball is moving. It spins like a top, turning once every day. Another way to think about this is that every day you travel all the way around the world. Just by standing still, the planet turns, carrying you with it. You can actually see the Earth turn when you watch the sun rise in the morning or set at night. It's not the sun that's moving, it's us. When you see the sun dipping below the horizon, you're actually seeing the speed of the turning Earth as we roll around from the day side of the planet over to the night side. And we're moving pretty fast to make it all the way around the world every day. In fact, here in southern Canada, We're moving at about 800 kilometers an hour just from the turning of the Earth towards the east. So that means that if the Earth was to suddenly stop turning, all of us would go flying off in that direction at 800 kilometers an hour. Imagine the mess that would make. Not only that, space is really, really large, and we are falling through it even faster than that. Yes, the Earth is whizzing through space faster than the space shuttle flies. We're circling around the sun, along with the 8 other planets. Mercury and Venus are closer to the sun than we are, which is why we're known as the third rock from the sun. While Mars, Jupiter, Saturn, Uranus, Neptune, and Pluto are all farther away than us. Together, we make up a planetary family, the solar system. But our journey doesn't end there. The sun moves as well, dragging all the planets, including us, on an even greater journey around our galaxy. Since we live inside our galaxy, we can't see it all at once. Just like you can't see the shape of a big city when you're on the street among the buildings.
Whoa, I can't see anything. Whoa, it goes fast.
But if we could travel far away, rise up above our galaxy, just like we had to rise high above the Earth to see that it was shaped like a ball, we would see that the sun is just one star in a vast city of stars, our home galaxy.
Wherever you guys. See that map?
Hey, look at that. There's Portugal. Where's the
Way back.
I know, but from our side, you look so tiny.
If we could look down on our galaxy, we'd see wonderful things. But getting high enough above the Milky Way to see it all at once is a journey that would take thousands of years with our current spaceships. Of course, it took us thousands of years to get a picture of our home planet Earth. It may take just as long to get a picture of our home galaxy. So all we see of the Milky Way from Earth is a band of stars stretching across the sky. Fortunately, astronomers have developed clever ways to figure out what our galaxy really looks like. It's really hard to get a sense of just how big space is because all the objects in it come in different sizes. For example, we think of the Earth as really big. Well, that's because we humans are really tiny by comparison. But the Earth is really tiny compared to the sun, which is a huge star. But then the sun is small compared to the Milky Way Galaxy, which is bigger still. Well, here in Hawaii is the home of artist John Lomberg. He's got a really good sense of how big things are in space because he paints them.
Well, one thing I found when I was doing the galaxy is that if you take the whole painting, which was about 6 foot by 8 foot, the first question people want to know is, where are we? Where's the Earth? And the way you find it is by connecting the corners, make an X. Now, the Earth is not in the center of the galaxy, but it is in the center of the painting, just where that X would cross. Now take a small coin, take a penny, and put it over the position of the solar system. Every star that you see in the night sky is underneath that penny. With one or two exceptions, everything that you can see is so nearby that it's just a penny's width in that 8 foot canvas. To take a spaceship and try to explore the galaxy, the fastest spaceship that we've ever made would take thousands of years, again, just to go the distance within that coin. Even the speed of light would take hundreds of years, and at the speed of light, it would take you 100,000 years to go from one side of the galaxy to another.
Have you ever wondered how many stars there are in the whole universe? Well, it's a number that is so big, it kind of is hard to get your head around it. But here's one way to think about it. Let's suppose we took our sun and we shrunk it down until it was as small as a single grain of sand. Let's see if I can get one on the end of my finger here. 1 grain of sand is our sun. Now, we know that there are other stars out there. All you need to do is go outside at night and look at them. If you live in a city and you look up, you might see a few dozen stars. So that would be, let's say, a pinch of sand. If you live in the country where the skies get really dark and the stars are like diamonds in the sky, you might see a few thousand stars. And that's, oh, let's say, a handful of grains of sand would be the number of stars that we can just see with our eyes. Well, we know when we look through telescopes that there are many, many more stars than that in the universe. And we also know that our sun is part of a huge city of stars called the Milky Way. Now, the Milky Way has a few 100,000 million stars in it. Now, how many grains of sand would that make? Well, a lot more than I can hold in my hand. In fact, the number of stars in our Milky Way galaxy would be about all the sand in that circle. What would fill your living room, or roughly one dump truck full of sand, is our Milky Way galaxy. A few 100,000 million stars. But our Milky Way is only one of about 100 billion other galaxies that are out there in the universe. So if you want to find out how many stars there are in the universe, you have to multiply the number of stars in our galaxy by 100 billion galaxies. That number doesn't have a name, but it's one with 22 zeros behind it. How many grains of sand would that make? Well, if you're thinking about this beach, that's not nearly enough. It's more sand than would cover this beach and all the other beaches on the entire planet Earth. That's unbelievable how much stars there are in the universe. And remember, our sun is only one of those grains of sand. What does that make us? We don't live on the sun. We live on the Earth going around the sun, so we are just an insignificant little piece of dust going around that grain of sand. Yes, the universe is unimaginably big. There are unimaginably huge numbers of stars out there, and we are incredibly small. But at least we know about it.
Well, the Earth is pretty huge, too. You know, we sometimes talk about how the Earth is such a tiny speck, but if you're actually out on the Earth, if you're in the middle of the prairies in Manitoba, and you start walking, the Earth seems pretty big. In fact, for most of human history, Earth was viewed as essentially an infinite space. You could just keep going and keep going and keep going and always find new lands and always find new things you hadn't seen before. So scale is very much a matter of your perspective. On the one hand, the Earth is enormously large. On the other hand, the Earth is very tiny. Well, it's the same with our galaxy. On some scales, our galaxy is so vast it's practically infinite in human terms. But then if you look at the larger universe, our own galaxy is still just a tiny speck. So scale is one of those things, is that it all depends on where you stand. It's an infinite staircase, and any place you stand on it can seem either very big or very small, depending on whether you're looking up or down the staircase.
When we look out across the universe, we see millions and millions of galaxies, and they come in all kinds of different shapes and sizes. But there's one galaxy that we cannot see, our own. We can't see our Milky Way galaxy because we live inside it. But we do know a couple of general things about it. First of all, we know that it's really flat, like a pane of glass. And we also know that, studying the stars around us, that the stars are arranged in a particular pattern. They seem to be in a spiral. There's a big clump in the middle, and then they form a spiral pattern around that clump that sort of looks like that. So there's the shape of our galaxy if you could see it from the outside, if you were above it. But we live close to one of these little grains of sand, so our view of the galaxy is edge on like this. Okay, so we can't actually see our galaxy because, again, we live inside it. The view we get from here on Earth is just a tiny part of it. But if you have a chance to go outside in the country, away from city lights, you can see that small part of the Milky Way. It's a dim band of light that arches right across the sky from one side to the other. It looks like milk because the stars are so far away, their lights blended together into a hazy glow. Ancient people thought that it was milk splashed across the sky, which is where it got its name. But astronomers know there's much more to it than that. So that's what our Milky Way galaxy looks like from the inside, our view down here on the Earth. Now, we won't actually get a photograph of our galaxy from the outside unless some aliens from deep space arrive and they show us the pictures that they took from up there. However, there are other ways of figuring out the shape of our galaxy from down here. Astronomers here in Penticton, BC, use this giant dish to pick up radio waves from space. That's right, radio waves, just like the ones playing music on your favorite station. Except this instrument picks up radio waves from the stars of the Milky Way.
Radio astronomy is the way that you can best study the Milky Way. The optical light that come from stars can't travel very far in the Milky Way because between the stars there are clouds of gas which contain dust particles. And as you would expect from dust, it absorbs light. So we can't see the light from stars that are more than a few thousand light years away from us, and that isn't large enough to see the entire galaxy. Now, radio astronomy studies radio waves which are emitted by these gas clouds in the Milky Way. One of the great things about radio waves is that they don't notice that there's dust in the galaxy. They just go right through the dust without being absorbed. And so by using a radio telescope, we can actually see what the galaxy looks like all the way to the center and then all the way to the edge, something that you could never do by looking at stars themselves.
Our weird world of the week is one we haven't actually found yet, but we can imagine it exists. Imagine a planet going around a star that's outside our Milky Way galaxy, floating high above it. Imagine the view the people of that planet would have, looking down on our beautiful city of stars. I wonder what they would think. Would they look down from their high position and imagine people on a planet orbiting one of those distant stars, people wondering what their position was in their huge city of stars? I wonder. They might feel isolated and very far away. They're planets in a very lonely place high above the galaxy. Perhaps they'd wish that they could be down here where we are, where the action is, wandering among the galactic city lights.
Oh, look, that's Medina. It runs to Chinatown. Look, this coordinate.
Hey, you found the CN Tower.
Yeah.
Congratulations, yeah? Have you found Sky Dome yet?
Yeah,
Straight down. It's right down there. It's the thing with the purple lights on it. Yeah. How would you folks like to go inside Sky Dome and help me with a demonstration to show how far apart the planets are, how big our solar system is?
Yeah.
Yeah? Okay, let's go. Come on. I got access. We can go inside. Whoa! Look at this. This is amazing. Wow. We got Sky Dome to use to make a model of the solar system. I mean, this is a really huge place, right? And what we're going to do is our volunteers here are going to become planets. What planets are you going to be here? What are you going to be?
Saturn.
Saturn, Pluto. Mars, Jupiter, Uranus. You can be Uranus. We're going to do the whole solar system here using this baseball diamond. Now, we got two problems to deal with here. One is size, and the other one is distances, because the planets come in different sizes, and they're really, really far apart. Now, you're probably used to seeing the Earth like this, right? These are the kind of globes you have at school or maybe at home. But if we use the Earth at this size, we don't fit inside Sky Dome. The sun would be bigger than the whole diamond. And Jupiter would be like a hot air balloon, and we'd need more than Canada to do the whole scale. So we can't use this. Now, if we go smaller than that, let's suppose we made the sun a marble. So if that's the sun, we could fit the whole solar system in here, but you wouldn't see the planets. They're too small. They'd be smaller than a piece of dust. So we can't use the marble. So what we're going to do is somewhere in between. We're going to make the sun a grapefruit, and all of you have the other planets. Now, let's just spread them out here on the ground so we can see how big they really are. We've got all 9 planets. So if the sun is a grapefruit, Mercury is going to be a poppy seed. Who's got the poppy seeds? Okay, here they are. Poppy seeds, the kind of things you find on donuts. Barely even see it. See the little tiny speck there? Okay, Venus and Earth are almost the same size, and they're the size of candy sprinkles. There we go. Okay, these are the things you put on muffins. Okay, so there's a candy sprinkle for Venus, and we need another one for Earth. There we are. Okay. Mars is going to be another poppy seed. It's a really small planet. Poppy seed there. And Jupiter and Saturn are fairly big planets. They're the size of M&Ms. They're Smarties. So, okay, there's one M&M for Jupiter. And here's another one for Saturn. Uranus and Neptune are about the same size. They're the size of popcorn kernels. So we got one here. And we got one there for Uranus and Neptune. And our final one is Pluto, which is also a very, very tiny little world. So there is roughly the scale of our solar system for size if the sun is a grapefruit. But we have a problem here. The planets are too close together. They're actually much farther apart than here. In fact, it's more than this stadium. So let's do a true scale of both size and distance. And I want each one of you to take one of these sheets of paper and put your planet on it. You've all got some markers. So just take them away and write the name of your planet or planets on there. And we're going to spread these out across the diamond and just see how big our solar system really is. Okay, let's get at it really fast. Okay, so now we have all our planets written out on cards. We need to do the distance scale. So let's take our planets. I'm going to take Saturn here. If you guys take the other planets, and let's go over to home plate and see how big the solar system really is, okay? So I'm coming over here. So we're going to put the sun, the grapefruit, right there at home plate. And I just happen to have a little chart here that has the distances worked out in steps, okay? So we're going to take some steps to the various planets, and Mercury is 12 steps from here. So let's just all walk this together. You're going to take fairly ordinary steps, 1/2 meter each, okay? So you want to count them out? Okay, we're going 12 steps, okay? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Who's Mercury? Okay, put Mercury right here and put your poppy seed on it, okay? You stay there. Now we need to go another 10 paces to get to Venus. And don't go over the picture mound. We got to go around it, okay? Okay, another 10 paces to Venus. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We're almost at the pitcher's mound. Okay, who's Venus? There we are. Okay, you put Venus there. Okay, now we need to go another 8 paces to get to Earth. 1, 2, 3, 4, 5, 6, 7, 8. We're at the pitcher's mound. Okay, who's Earth? There we are. Okay, so you stay there. Now we need to go 16 paces to get to Mars. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Not quite to second base. There's Mars. Okay, you stay there. And now we need to go to Jupiter. Now, Jupiter's a long way from here. Are you ready for this? Yeah. We got to go 110 paces. You ready? Yeah. Okay, we got to do this quick. Okay. 1, 2. Seven, 8, 9, 10. Woo! That's Jupiter.
110.
110. Okay, you're Jupiter, and I'm going to be Saturn. And holy smokes, Saturn is another 130 paces beyond here. You stay here. I got some walking to do. 1, 2, 3, 4, 5, 6, 7, 8. I ran out of room. The stadium isn't big enough for Saturn. I have to actually go outside the field and up into the stands to make it. But look at how far we are. A whole baseball stadium, and we only got halfway out of our solar system to Saturn. Hi, guys. Hey. So, this is how big our solar system would be if the sun was a grapefruit and the Earth was a candy sprinkle. And this only takes us out to Saturn. 128, 129, 130. This is where I would have to be just to be Saturn. I'm up in the stands. There's still 3 more planets to go, and none of them fit within this stadium. Uranus, Neptune, and Pluto are all outside the building, blocks away from here. The solar system is really, really large, and the planets are very small. Most of it's made of empty space. Come on, guys, we got some more walking to do. Okay, out of here. Let's go. Okay, 42, 43, 44, 45. Okay, we're outside the building now. We have 250 more steps to go. Come on. 43, 46, 47. It took a lot more walking outside the building to complete our model of the solar system. It was another 388 steps to Neptune and 230 more steps to Pluto. That was quite a hike. 3, 24, 25, 6, 27, 28, 29, 230. That's where Pluto goes. Wow. And we are now at the edge of our solar system. And remember, this is when the planets were really small, when Pluto was nothing more than a poppy seed you could barely see. The Earth was nothing more than a candy sprinkle. And even at that distance, we're a half a kilometer from the grapefruit that's our sun at home plate. Boy, and if you think that's bad, if you want to walk to the next grapefruit, the next star, that would be in Vancouver, halfway across Canada. You guys want to walk to Vancouver? No! Okay. The universe is incredibly large, and if we tried to show you the whole Milky Way, we'd run out of Earth. It is really huge. But now we know our cosmic address. So here it is. Put your name, then your street, then your city, mine is Toronto, your province, Ontario, your country, Canada, planet, Earth, solar system. We are in the Orion arm of the Milky Way Galaxy, which is part of the local group of the Virgo supercluster in the universe. That's our cosmic address.
And we have liftoff. Liftoff of the Space Shuttle Endeavour.
When our rockets take off, it looks like they're roaring off across the universe. But really, they don't go very far. The Space Shuttle, for example, can only go into orbit around the Earth. It can't go any further. The farthest that humans have ever traveled is to the moon. But that's just our cosmic backyard.
Stand out here in the wonders of the unknown at Hadley, I try to realize there's a fundamental truth to our nature. Man must explore.
We've sent robots to other planets, but it takes them months and years to reach those other worlds. One of them, called Voyager, took 12 years just to get to Neptune. It's now beyond Pluto, but it'll take thousands of years before it gets to another star. Our rockets are too slow. Humans can't travel out of the solar system. We need faster rockets. So, does all this talk about huge space and little tiny planets make you feel kind of small and insignificant? Yeah, well, I mean, we are small, okay? The universe is really big, we're really tiny. But you know something? At least we know that. Nobody else in the whole history of humanity has ever known our true cosmic address. We are the ones to figure that out, which makes us pretty lucky. So there are even more reasons to keep your heads up!